4, I have a 350 milliliter sample of gas with a temperature of, and I have another degree Celsius, so I'm going to automatically add 30 plus 273, and I get 303. And so that's a temperature. And then I have a pressure of 1.20 atmospheres. So we're asked what temperature would be needed for the same amount of gas to fit into a 250 milliliter, so it's a volume, flask at 1 atmospheres. So that's a pressure. So I have 350 for my initial volume. My initial temp is 303. And my initial pressure is 1.2. And we're asked what temperature, so I'm going to put a question mark there. And I have 250 for my final volume, and then 1 for my final pressure. Now, whenever we have 3 going on here, I'm going to cross out N. Whenever we have 3, it's really hard to kind of judge what the effect is. But we have a decrease here, and we have a decrease here, okay? So we should end up with a decrease here, kind of just thinking about that a little bit. But it's difficult to just assume a relationship before you actually do the math, whenever you have more than 2 variables changing. Okay, so we have 3 variables, so these are the 3 variables I'm going to pick out of my equation from the top. So I have pressure, volume, and temperature, and I do not have number of particles. So P2, V2 over T2. And you can see that when I cross multiply this, it's going to get a little messy. So on one side I have T1, P2, V2. On the other side I have P1, V1, and T2. And then I just plug things in. So 303 is my initial temperature. My final pressure is 1. My final volume is 250. And on the right side of the equation, my initial pressure is 1.2. My initial volume is 350. And my final temperature, I do not know. So I'm just going to write T2. So I'm going to solve everything, and again, I've kind of run out of space here. So I'm just going to kind of keep writing up here. So I am first going to solve the left side. So 303 times 1 times 250, and we get 75,750. So 75,750 is equal to, and then for this side, we're going to do 1.2 times 350, and we get 420. So 420 T2. So from this, it looks a lot like the other problems that we've done. So I want to isolate T2. So I divide each side by 420, and 75,750 divided by 420, and we end up, 420 cancels out on that side, so T2 is equal to 180.36, and my temperature is in kelvins. And you can see I kind of ran out of room there, so I just kind of wrote it below.